Okay, let's get some practice evaluating logarithms. So here we have log base 2 of 8. And we actually looked at this one in the previous video, but let's start fresh with it. So again, what I should be getting is when I have this equal something, I'm looking for an exponent over here. That's my missing piece of information. So what I'm thinking to myself off to the side is I have base 2. I don't know my exponent, but I know the outcome should be an 8. And I'm trying to think of what exponent makes that work. In this case, we would need an exponent of 3. So my final answer is 3. I just kind of like this setup as side work to help me evaluate it. All right, log base 5 of 25. So I'm thinking, what exponent do I need on 5 to get a 25 out? Well, I would need a 2. So again, I'm fitting 5 to what exponent would give me 25? Well, I would need to know that 5 squared is equal to 25. Log of 100, again, there's a hidden base here that's a base 10. So I'm thinking 10 to what exponent would give me 100? And that would be an exponent of 2. Okay, this one's pretty fun because I'm thinking 3 to what exponent gives me 3 to the negative 2? Well, they're showing me right away that that's the answer that I need. So it's almost like there's this cancellation of log base 3 with a base 3 of an exponent. So we're just left with that exponent that they're showing us there, as long as those bases match up with each other. So this right here is just a negative 2. Okay, a little tricky one here. And what could help is to kind of think about how 1/4 works as a base 2. So what I could do is think of this as 1 over 2 squared, which is the same thing as 2 to the negative 2 power. All of those are the same thing. So if I wanted to, what I could do is rewrite this as a log base 2 of 2 to the negative 2 power. And with that, I'm seeing the exponent that I need on 2 of a negative 2. So something that I think about is if I have this like nice whole number base and then I'm seeing a fraction come through, the outcome should be negative. We're looking for a negative number because that's what's going to create fractions over here, because that's what moves things to denominators. All right, log base 4 of 1. So I'm thinking 4 to what exponent would give me 1? And that's going to be a 0. And this is a property that we use quite a bit. In fact, we could just say in general, log to any base of 1 has to be a 0. And it's all because x to the 0 power is equal to 1. So it doesn't matter what the base is. If we have a value of 1 coming out, we would need an exponent of 0. Okay, a few more tricky cases here. This one isn't too bad because with natural log, we're thinking of base e. So I'm thinking e to what exponent would give me e cubed. Again, they're showing me the exponent directly, so I just need to write down that exponent that we're seeing. This is also base e, and this is creating a fraction, so I'm thinking that we will need a negative exponent, but just to see for certain that if I have this 1 over e to a positive 1, to bring that up to the numerator, I would need e to the negative 1. So I need an exponent of negative 1. And then our very last case here, log base 6 of the square root of 6. With radicals, it'll help to change to rational exponents. So thinking of this as log base 6 of base of 6 to the 1/2 power. Because then I could see 6 to what power would give me 6 to the 1/2? Well, I just need that exponent right there of 1/2. So when you start to see radicals, we should be getting fractions out for our exponents because of how those rational exponents relate to radicals.